Trigonometry, which in Greek roughly means triangle measure, is a branch of mathematics that studies the relationships between the side lengths and the angles of triangles. Cosine is one of the big three trigonometric functions, along with sine and tangent. Its primary use is finding the length of the side of a right triangle that is adjacent or connected to an acute angle with a known measure. Today we're going to dig deeper into what cosine functions are all about and take a look at some problems where you'll find one. Let's get started. Let's jump right in and give it a try with this example problem. Cosine, which is commonly abbreviated to three letters as COS, is the ratio of the side adjacent the angle we know or want to know over the hypotenuse of the right triangle. Remember that the hypotenuse is the longest side and is always opposite the right angle, which is the largest angle in any right triangle. And a ratio is just a fraction, so we can write it like this. Cosine of the angle is equal to the adjacent over the hypotenuse, or A over H. If you've studied trigonometry before, you're probably familiar with SOHCAHTOA, which is a way to remember how each of the big three trig functions are formed. The second part of it, CA, helps us remember that cosine is equal to the length of the adjacent side divided by the length of the hypotenuse. In this problem, we know one angle and two of the sides. The side we don't know is adjacent to the angle we know, so we need to use cosine to find it. We do so by setting up a simple equation like this. Cosine of 36.87 degrees is equal to x over 5. The cosine of the angle we know, 36.87 degrees, is equal to the length of the adjacent side, which we're trying to find. So we use a variable over the length of the hypotenuse, which is 5. From here, we can find the cosine of 36.87 degrees on a calculator. We type in 36.87 and hit the cosine key to find that it is equal to 0.799, which we can round to 0.8. So now our equation looks like this. 0.8 equals x over 5. Multiplying both sides by 5 results in 4 equals x, so the measure of the adjacent side is 4. You may have recognized that this is a 3, 4, 5 special right triangle, since the hypotenuse is 5 and the other two sides measure 3 and 4. We see this special triangle often in standardized tests, so it's a good idea to try and recognize them when they appear. Note that the sides can also be multiples of 3, 4, 5. So 6, 8, 10, or 9, 12, 15 triangles are also 3, 4, 5 right triangles. Okay, back to cosine. We can also use cosine to find an angle of a right triangle if we know the length of the adjacent side and the length of the hypotenuse, which is always the side opposite the right angle. Let's try one of those. Let's see what we know. It's a right triangle, so trigonometry can definitely be used. We're trying to find an angle since it's marked with an x. We know the hypotenuse, which is 13, and we know the side that is adjacent to the angle we want to know. Since we know the adjacent side and the hypotenuse, that means we need to use cosine. Let's set up our equation. Cosine of the angle equals adjacent over hypotenuse equals A over H. So, cosine of x is equal to 12 over 13. In the first problem we did, we took the cosine of an angle and the calculator gave us a number. For this problem, we want to do the opposite. We know the value of the cosine of our angle and we want to find the measure of the angle. So what we need is the arc cosine, which is often labeled as a cos or even more commonly as cos to the negative 1 power or cos inverse, as you'll see on most HP calculators. This is the inverse operation of cosine. This is accessed by hitting the second key and then the cos key. Okay, so we type in 12 over 13 and then second and then cos, and our calculator displays 22.619 or approximately 22.62 degrees. We found our answer. That answer makes sense when looking at our triangle. It's important to remember that you should only trust the proportions of the diagram if it's drawn to scale. On standardized tests, it will often be indicated if the drawing is not to scale. Cosine functions can also be graphed. Let's set up a graph of the basic cosine function. This is a cosine wave. It looks a lot like the more famous sine wave, but it's phase shifted by pi over 2 radians. Let's overlap the cosine and sine functions so we can see the shift. We can clearly see that they have the same shape. The sine wave in green starts with a y value of 0 when x is 0, while the cosine wave starts with a y value of 1. Just like a sine wave, a cosine wave has a maximum y value of 1, and its minimum y value is -1. This is true when the cosine or sine function hasn't been modified. We can change the height or the amplitude of these functions by multiplying them by a coefficient, like this. Y equals 2 times cosine x. This will simply double the y values of our base function, y equals cosine x. Let's take a look at this with our original cosine function in red and our height doubled cosine function in blue. We can see that our functions have the same frequency, which means that they have the same period or distance between their peaks. But the two graphs do have a different amplitude. The blue graph is stretched vertically and has y values as high as 2 and as low as -2, just as we'd expect. And that's all there is to it. As you can see, cosine comes in handy when graphing, solving problems with angles, and determining trigonometric identities. Thanks for watching, and happy studying.